Hey guys, welcome back to another video. In this video, you will learn about the second derivative test. And firstly, as a side note, 50% of you guys that watch the videos aren't subscribed. And I know that it doesn't mean a lot to you, but if you would just hit the subscribe button right now, it would mean a lot to me. And also, there is a calculus and algebra 2 playlist in the description that you can watch to review for your finals or midterms, and all the videos that you need in the class are in there. So now back to the video. So the second derivative test states that if f double prime of c is less or is greater than 0, then there's a relative minimum at c comma f of c. And if f double prime of c is less than 0, then there's a relative maximum at c comma f of c. And then c stands for a critical number. So, knowing this, take a moment or two to copy this down in your notes, and when you're done, come back. So, now that you've copied this down in your notes, let's go to our first example problem. Use the second derivative test to find the x values of the relative extrema of f of x is equal to x cubed minus 3/2 x squared. Justify your answer. So, what the question is asking us to do is find the relative extrema of f of x equals x cubed minus 3/2 x squared using the second derivative test, and then afterwards to justify our answer. So, let's get right into this. Our first step here would be to find the critical numbers, but in order to do that, we have to first find the first derivative. So, f prime of x is equal to 3x squared minus, and then this would just be 3x. Now, in order to find the critical numbers, we set the derivative equal to 0, and then we solve for x. So, this would just be 3x times x minus 1. And we can solve for x, and we see that x is equal to 0 and 1. And now these are our critical numbers. And actually, I'm just going to erase this 1 real quick because it's in the way. So let's write right there. Yeah. So our second step now would be to find the second derivative. So in order to find the second derivative, we take the derivative of the first derivative. So f double prime of x is equal to, and this is just equal to 6x minus 3. Now we have to plug in our critical numbers into our second derivative. So f double prime of 0 is equal to 6 times 0 is 0 minus 3, so it's just negative 3. And f double prime of 1 is simply equal to 6 times 1, which is 6, minus 3, which is also 3. So, now that we have this, we can go to our notes again. And we see that if f double prime of c is greater than 0, then there's a relative minimum at c comma f of c. Now, let's look down. We see that negative 3 is less than 0, while positive 3 is greater than 0. And if we look back up, there should be a relative minimum when f double prime of c is greater than 0. And what do you know? There's a relative minimum at f of 1. So let's write that down. Relative minimum at, and then it would just be 1, comma, and then we have to first plug back into our original equation here. And if we look at our original equation, it should just be 1 minus 3/2, which is equal to negative 1/2. There's a relative minimum at negative 1/2, and now we have to justify our answer because, and we simply say that f double prime of 1 is greater than 0. Now, what about the relative maximum? Well, for our relative maximum, if we look back at our notes, we see that there's a relative maximum when f double prime of c is less than 0. And in this case, it looks like f double prime of 0, which is equal to -3, is less than 0. So there's a relative maximum at 0, comma, and we have to plug back into our original equation, so that would just be 0. So there's a relative maximum at 0, comma 0, because, and we simply say it is because f double prime of 0 is greater than 0, or it's less than 0, my bad. So this is how you would use the second derivative test to find a relative extrema and justify your answer. So if you enjoyed this video or it helped you, please consider subscribing. As always, have a good day and good luck on your homework and tests.